Hello friends, I am Ajit Agrawal and in this class of Physics for class 12, I will continue unit electrostatics. This is second part of previous class. In this part, I will discuss you about Coulomb's law and principle of superposition. What is said by Coulomb's? Coulomb ने क्या कहा था कि if there are 2-point charges, suppose I am drawing 2-point charges here. Suppose this is charge Q1 and at a distance of r from Q1, there is another charge Q2. Then both will exert the electrostatic force on each other, depending on nature of charges. Suppose both are of similar type, say positive, then both will repel. If one of the charge among them is negative, then both will attract. Means electrostatic force may be attractive or repulsive, depending upon nature of charges. So a force will act between them. This force F will directly proportional to product of magnitude of charges and inversely proportional to square of distance. These 2 points can you consider from these two points. Okay, if you join them, then you will get relation like this: F proportional Q1 Q2 by R square. So if you remove proportional sign, then you will put a constant K. What is K here? This K is 1 upon 4 pi epsilon 0. Here, this symbol is epsilon 0. Or you can say epsilon naught. This epsilon naught is a constant whose value is 8.854 multiplied by 10 to the power minus 12. And unit you can frame from this formula. If you have to know the unit of epsilon 0, then what will you do? Shift epsilon 0 on left side in place of F and shift force in place of epsilon 0 in down in denominator. Then charges are measured in coulomb, distance is measured in meter, distance square meter square जाएगा, or force that will be in denominator will be measured in Newton. On that basis, you will have unit Newton inverse meter minus 2 coulomb square. This is a permittivity of free space. Next topic of this class is force between multiple charges. That is superposition principle. Then what is given in this principle? It is said that if you have few charges like Q1, at some distance there is Q2 and another Q3. Yeah, all these may be positive, all may be positive, all may be negative, or some positive, some negative. Suppose I am taking Q3 as negative. And if you have to calculate the force on another charge Q naught. Suppose this Q naught is a unit as positive charge, okay? Then several forces, then forces due to these Q1, Q2, Q3 will act on Q naught. Then first of all, you will show direction. By this Q1, a force will exerted on Q naught in this direction along the line joining. The electrostatic force always acts along the line joining between two charges, okay? It is also given in that Coulomb's law. So this Q1 will repel Q naught because both are positive. Q2 will also repel Q naught in the same direction as F1. Say it is F2. But Q3 that I have taken it as negative. The negative charge will attract positive charge towards itself. Okay. That is F3. Now, if distances are given, suppose from Q3 up to Q0, it is R3. From Q2, that Q0 is at a distance R2. And from Q1, suppose it is at R1. Okay. So first of all, you will calculate F1 by Coulomb's law formula. The formula was K time Q1 Q2 upon R square. So in this formula, what will you substitute? If you are calculating F1 is the force acting on Q0 due to Q1, then you will have constant K, Q1 remain Q1, this one, but Q2 will be test charge Q0, Q1 Q0 upon R1 square. The distance that you will take always from the source charge. These charge will produce a electric field are called source charge. Similarly, you can calculate force acting on Q0 due to Q2. अब Q2 से हम force निकालेंगे, तो F2 will be K times Q2, and the charge is remain same Q0 upon distance from Q2 up to Q0 is R2, and finally R3. This is a force acting on Q0 due to Q3. It will be K times Q3 Q0 upon R3 square. You can see that F1, F2, F3 all are linear but opposite in direction in case of F3. So according to principle of superposition, if you are calculating net force F, then you will add it by direction, means vector sum. You will calculate a vector sum of all the forces. Force F1 with arrow mark, then F2, but F3 in opposite direction. So you will subtract it from rest two forces. Is it clear? By this way, you can calculate the net force. So what was the principle? According to the principle of superposition, the force on any charge, say here Q0, due to number of other charges like Q1, Q2, Q3, the vector sum of all the forces on that charge due to other charges, okay? But taken one at a time. I suppose Q0 is fixed. First of all, I will take Q1, then you will take Q2, then you will take Q3, and then do vector sum. Now come to numerical problems. The first numerical given is here. What will be electrostatic force between 2 point charges of magnitudes plus 2 microcoulomb and plus 4 microcoulomb repel each other with a force of 20 Newton? Understood? 20 Newton force is given initially. So first of all, you will make the data. So with a force of 20 Newton, when a charge of minus 6 microcoulomb is given to each of them. अच्छा, इसमें गिवन ये है कि इनिशियली आपको चार्ज प्रोवाइडेड है +2 microcoulomb. The second charge Q2 is +4 microcoulomb, but distance between them is not given, so take this distance as R. Okay, calculate force between Q1 and Q2. By Coulomb's law, the formula for force is F equals K Q1 Q2 upon R square. The K will remain K, Q2 into Q1 upon R square. The value of constant is 9 multiplied by 10 to the power 9. Again, if you have to calculate unit of K, then shift R square and Q1 Q2 on left side. Okay, that unit will be Newton meter square per coulomb square. Q1 Q2 given R 2 microcoulomb, change them into SI unit of coulomb like 10 to the -6. Similarly, 4 microcoulomb means 4 into 10 to the power -6, because 1 microcoulomb is 10 to the power -6 coulomb. R is not given, it will remain as it is. Okay, so this is equation number 1. This is the force in case when no additional charge was given. Now, in the second case, when you are providing -6 extra charge, then what will be new charges? Now, new charges I am taking it as Q1 dash. The original charge was plus 2 microcoulomb. You are giving minus 6 microcoulomb more. The total charge is minus 4 microcoulomb. Is it clear? If you have any problem, you can ask by means of comment box. Q2 dash. Q2 dash, the initial charge was plus 4 microcoulomb. After giving off minus 6 microcoulomb, it will be minus 2 microcoulomb. Now you can see that both charges are negative. It means similar charges are there, so that force, the type of that force will be repulsive. You have to calculate new force after giving the charge of 6 microcoulomb extra. So what is the new force? New force F dash will be, again I am taking directly the constant value 9 10 power 9. Q1 Q2s are 4 multiplied by 10 to the power minus 6 multiplied by 2 microcoulomb, that is 2 into 10 power minus 6 divided by r square. Again, r square not known, take this equation number 2. So you can use these two equations to calculate f dash. How? Dividing equation 2 by equation 1. So like term will cancel out. Dividing equation 2 by equation 1. So f dash divided by f will be how much? F dash is 9 multiplied by 10 to the power 9. Charge Q1 was 4 into 10 to the power minus 6. Charge Q2, 2 into 10 to the power minus 6. Whole upon r square. This is F dash. Now F1 is 9 into 10 to the power 9. 2 into 10 minus 6. 4 into 10 minus 6. Divided by r square. Now you can see that r square will cancel out. Similarly, 9 into 10 by 9 is cancel out. 10 minus 6, both 10 minus 6 will cancel out. Okay. 4 will cancel out and 2 will cancel out. So you can see all the terms are getting cancelled. So new force will be equals to original force. Okay. That will remain same. One more numerical problem is when held apart a certain distance, two spherical conductors B and C with similar radii and carrying equal charges repel each other with a force F. What is given to you? That you are given two charges. Say this is B, this is C. Both are similar conductors having same radii and equal charges. Suppose equal charges given are Q and Q. Both repel each other with a force F. Because a similar type of charge, so they will repel. Third spherical conductor and of same radius as B, but no charge, means you are provided another third spherical conductor. Say that third spherical conductor is P. So it is brought in contact with B. Suppose you have to touch first with B and then with C. Then with C. क्वेश्चन जो ध्यान रखिए किस तरह से आपको दिया हुआ है, एक एक स्टेप पढ़ेंगे. जैसे थर्ड स्फेरिकल कंडक्टर विद सेम रेडियस एज बी, साइज सेम है बिकॉज बी और सी ऑलरेडी आइडेंटिकल थे, और पी का साइज भी बी के जैसा, तो पी का साइज सी जैसा भी हो गया, तो आइडेंटिकल ये भी हो गया. बट इट हैज नो चार्ज, इसमें कोई चार्ज गिवन नहीं है, तो हमें इसका जो चार्ज है वो जीरो लेना पड़ेगा. इनिशियल चार्ज इज जीरो, बट यू हैव टू टच first with B and then with C and ultimately remove from both. फिर इसको remove कर देना. What is a new force of repulsion? तो ये क्वेश्चन हमारा है एडिशन ऑफ The charges are additive nature property this part. Okay. So we can see that first what you are doing first you will touch P with B. कभी भी इस तरह का क्वेश्चन होता है तो हम लोग पहले टोटल चार्ज फाइंड करते हैं. On touching P with B. If you touch P with B, first of all you will calculate total charge of the system. Total charge on P and B. It will be, because charge on B was Q assumed and charge of P was initially 0, because it was given that the size size is similar to that of B, but it has no charge. What is the total charge? It will be Q. But on separating them, charge on B will be half that of initial, means Q by 2. And similar in case of charge on. Understood? तो अब P पर हमारे पास चार्ज आएगा Q by 2. And this will be now, ये चार्ज तो नहीं रहेगा, अब ये Q by 2. अब इस Q by 2 चार्ज के स्फेरिकल कंडक्टर को हम C से टच कर देंगे, तो फिर से टोटल चार्ज निकालना पड़ेगा. On touching P with C, again total charge on P and C. The charge on P was Q by 2, while the charge on C was Q. Then by LCM method you can calculate total charge. It will be 3Q by 2. Next step similar, ये हमने टोटल चार्ज निकालेंगे. टोटल चार्ज निकाल लिए. आफ्टर कैलकुलेटिंग टोटल चार्ज अब इनको सेपरेट कर दें. On separating, charge on P will be half of total. Total में 3Q by 2 निकाला था, तो it will be 3Q by 4 now. And same on C. It means कि now we have charge on B and C both, but new charges. Now new charges on B it will be 3Q by 4, as well as in case of C. Sorry, charge on B was Q by 2, na? Charge on B was Q by 2 because you are not touching B and C, na? You have touched P to B, the charge will be half, and if you touch P to C, charge will be 3Q by 4, 3Q by 4. Now you have to calculate the net force between Q by 2 and 3Q by 4. So the force acting between B and C will be F equals 9 multiplied by 10 raised to the power 9. Charge on B is 3Q, charge on C is 3Q by 4 multiplied by charge on B was Q by 2 upon distance between them was R square. So you can see that the calculation will be 3 upon 8 times of 9 multiplied by 9. Q into Q is Q square upon R square. इस तरह से लिखने का एम ये है, ये शो करना कि दिस इज इनिशियल फोर्स। ये तो नोन था ना कि इनिशियली चार्जेस थे वो क्यू और क्यू थे। अगर बीच की डिस्टेंस आर है तो इनिशियल फोर्स होगी 1/4πε0 क्यू स्क्वायर अपॉन आर स्क्वायर। तो दिस इज ओरिजिनल फोर्स। सो न्यू फोर्स एफ डैश विल बी 3/8 times of original force. Understood? This is your final answer. अगर एग्जाम में न्यूमेरिकल प्रॉब्लम में इनिशियल फोर्स का कोई मैग्नीट्यूड दिया है तो हम उसको एफ की जगह पुट कर देंगे और टोटल फोर्स कैलकुलेट कर लेंगे। तो दिस वाज द फाइनल क्वेश्चन। अगर आपको इन क्वेश्चन से रिलेटेड कोई भी क्वेरी हो तो आप मुझे कमेंट बॉक्स में लिख के भेज सकते हैं। और अगर आपको वीडियो पसंद आया हो तो इसे ज़्यादा से ज़्यादा अपने फ्रेंड्स में शेयर करें। और अगर आपने चैनल सब्सक्राइब ना किया हो तो उसे सब्सक्राइब करें, जिससे कि आपको न्यू वीडियोस तुरंत की तुरंत मिल सकें। ओके, थैंक यू।